So far we have seen two different types of sequences. We have seen arithmetic and we've seen geometric sequences. And what we want to do is, first let's talk about what arithmetic sequences are, and then we'll hold off on geometric sequences for another day. But arithmetic sequences are a sequence of numbers. You've seen them before. Let's just give a formal definition to what they are. It is a sequence in which each term differs from the previous one by the same fixed number, so we call this a common difference. It can also be referred to as an arithmetic progression. So the key term here is a common difference between all of my terms in the sequence. So let's say I start off a sequence with 5, another term could be 8, and then now you can see I have a difference of 3 between 5 and 8. So the next term in my sequence must have a difference of 3 as well, and so on and so forth. I can continue this pattern as long as I want. And really the kicker here is that it has this common difference. So we are adding 3, we are adding 3, adding 3, and that's what makes this an arithmetic sequence, because I'm adding 3. It's a common difference, so it could also be subtracting 3. I could have just as easily started with 5 and subtracted 3, and now I have, I guess that would be positive 2, and then I could have negative 1, I could have negative 4, and so on and so forth. As long as there's you're adding or subtracting by the same amount, that is an arithmetic sequence. So let's talk about what this looks like in an algebraic sense. So we'd say that the set u sub n is arithmetic. This symbol here means if and only if, and I'll talk about what that means in a second. Maybe I'll jot that down, if and only if. And I think that this is going to disappear on my next slide. If and only if u sub n plus 1 minus u sub n. What this means is if I subtract basically two consecutive terms, u sub n, if that's just any general term, the u sub n plus 1 is whatever the next term is. So if I subtract those two and it's equal to some constant number, then it must be arithmetic. So we'd say this is true for all positive integers n. Those are my natural numbers, my counting numbers, where d is called the common difference. So what does that mean? What that means is, since this goes back and forth, I can prove that something is arithmetic if I can show that the difference between two terms is a constant, or I can say, well, I'm going to tell you that this sequence is arithmetic, therefore I must conclude that this must be true. So this is just like an algebraic definition of what these arithmetic sequences are. And really this is kind of the kicker, that when I subtract two consecutive terms, I get some constant number. We call that the common difference. So let's just, you can just watch this piece here. I want to take three consecutive numbers, and I want to just show a little bit about what we can do with them. If I say that A, B, and C are consecutive terms, that means that if I take the difference between B minus A, this would be two consecutive terms, and I'm subtracting them, that should equal C minus B. And let's just think about that for a second. If I associate A, B, and C as, let's say this is the first term, this is the second term, this is the third term, then if I take the second term and subtract the first term, this is kind of like u sub 2 minus u sub 1. You can think back to the last slide where this is like u sub n and u sub n plus 1. That should equal whatever u sub 3 minus u sub 2 is. If it's a common difference, then it'll always be the difference. They'll be the same between two consecutive terms. So what I can do with that then is I can kind of rearrange all of this. I can get all the b's to the same side. So this is going to turn out to be 2b is going to equal a plus c. And if I divide both sides by 2, then I get b is going to equal a plus c over 2. So this is kind of like what I'm concluding. This b term is a plus c over 2. And you might think like, okay, well, who cares? Why does that matter? Really, the important thing to take out of this is that B is the average of A and C. So you can see that the way I find an average of two numbers is I add them up, divide by 2, and that's what I've done here. So B is literally smack dab in the middle of A and C. It is the average or the mean between those two. So that's just kind of helpful if we have two terms that are two apart from each other. I can find that middle term just by taking the average of those two. So let's come up with a general term for, or formula to generate some sort of general term in the arithmetic sequence. So what I'm going to do here is that this is going to be kind of like a little bit of a proof. We're going to start off with some some value u or some term u sub n, and we'll say that the common difference is d. So that's just, this is by definition what makes something an arithmetic sequence, if it has an initial term and it has a common difference. So what we're going to do then is we could say, well, u sub 2 must equal whatever the first term is plus whatever that common difference is. And over here I just kind of have a numerical example in case we get too bogged down with the algebra. In this case, my u sub 1 would be this 2, u sub 2 would be 4, u sub 3 would be 6, u sub 4 would be 8, u sub 5 would be 10. And in this example, it looks like I have a common difference of, I'm adding 2 between each term. So keep that in mind if you need to kind of parlay between the algebraic piece and the numerical piece. So we could say that u sub 2 equals u sub 1 plus d. I can also say that u sub 3 is going to equal u sub 1 plus 2 times d. And let's think about what that means. If I start at u sub 1, I add whatever that common difference is twice to get my third term. You can verify that over here. And then I can also say that u sub 4, let's go one more color here, u sub 4 is going to equal u sub 1 plus 3d. And again, same argument. If I start here, I'm adding that common difference 3 times to get to my u sub 4. So why do we care about that? Well, we can conclude that if we can look at this pattern here, all of these 3 examples, let's see, let's go green, have a u sub 1 in them, right? So in general, I could say that u sub n, this would be any term in my sequence, is going to equal whatever my starting term is, and then I'm adding some variant of my common difference. So when I'm looking for my second term, I'm just adding the difference. When I'm looking for my third term, I'm adding 2 times that difference. When I'm trying to figure out what my fourth term is, I'm going to add 3 times that difference to my first term. So hopefully what you're kind of seeing here is that value that links the term number and how many of these common differences I'm adding. There's always a difference of 1. When I'm looking for the third term, I'm adding 2 times the common difference. When I'm looking for my fourth term, I'm adding 3 times the common difference. So we can generalize that. And we can go back to our formula and we can say this is then going to equal u sub 1 times the common difference, or excuse me, plus the common difference times whatever that n term that you're looking for is minus 1. So when I'm looking for the third, if we were to jump, well, let's jump to the fourth term. If I'm looking for the fourth term, then that should equal u sub 1 plus my common difference times 4 minus 1. And that's exactly what I had here. 4 minus 1 is 3, so looking for my fourth term, I take the initial term and I add 3 times the common difference. Really, this is kind of like a linear equation. The only difference with this is we don't think of a starting point when like x is 0, but we think of a first term rather than starting at a 0 term. So that's really the only difference with this and linear equations. And that's why I was saying before that this is conceptually pretty familiar. We're just adding numbers, right? But because we have this like very, very important formula, my general formula, I'm going to just box this and star this because this is the one that we really want to get down here. Here is my my formula for finding any term in an arithmetic sequence. And you know what I'm going to also do? Let's just kind of throw some arrows pointing to specifics. So in this formula here, this is going to be any term at the n place. This is going to be my initial term, my initial, I'll say, or first term. D, that's my common difference. And I'd say then that n is kind of like the index of that term. And when I say that term, I'm meaning this u sub n. So u sub 3 is when n is equal to 3, it's the third term. So if we kind of got that locked in, we can now use this formula. And that's what we're going to do in the next video. We're going to actually apply this formula to some examples. But really it's important we just get this concept down moving forward. So make sure you have all of this at least, and then I will see you in the next video for some examples.